Myself, Sulfath CY, Assistant Professor in Department of Software Development and System Administration in MES College, Marampally.
Hello all. Today I am going to discuss about continuous memory allocation and non-continuous memory allocation in operating system. Continuous memory allocation. Continuous memory allocation is basically a method in which a single continuous section or part of the memory is allocated to a process or file needing it. In continuous memory allocation, in order to achieve or process in order to execute a process, a continuous section or part of memory is allocated to that process. Because of this, all the available memory space reside at the same place together, which means that the freely unused available memory partitions are not distributed in a random fashion here and there across the whole memory space. Because whenever a process is allocated into a single place together, there is no unused available memory partitions in the memory. This is a picture of a continuous memory allocation. Here the colored cells represents a process in which the partitions are arranged in a continuous manner. Next, continuous memory allocation can be divided into two types: fixed sized partition and variable sized partition. First, we can see what is fixed size partition. In this partitioning, the number of partitions in RAM is fixed, but the size of each partition may or may not be the same. As it is a continuous allocation, hence no spanning is allowed. Here, partitions are made before execution or during system configure. So in fixed size partition, the partitions are made before execution or during system figure, and the number of partitions in the RAM is fixed, but the size of each partition may or may not be the same. Because it is a continuous allocation, hence no spanning is allowed. Spanning means allocating or arranging the unused spaces together. That is called spanning. This figure shows the example of a fixed size partition. Here, the entire memory is divided into 4 blocks. First block is 4 MB, second block is 8 MB, third block is 8 MB, and the last block is 16 MB. Here we have 4 processes. The first process P1, which is of 1 MB, which is allocated to the first block, which is of size 4 MB. So we can see that 3 MB space is made free there. Okay. Then the next process P2 is of 7 MB, which is allocated into the block size of 8 MB, and the process P3 is of size 7 MB, which is allocated into 8 MB block size, and so on. Then what are the different advantages of fixed size partitioning? The first advantage is it is easy to implement. Algorithm needed to implement fixed partitions are easy to implement. It simply requires putting a process into certain partition without focusing on the emergence of internal and external fragmentation. Second advantage is little OS overhead. Process of fixed partitioning requires lesser access and indirect computational power. The next important topic is disadvantage of fixed partitioning. The first disadvantage is internal fragmentation. Internal fragmentation means main memory use is inefficient. Any program, no matter how small, occupies an entire partition. This is cause an internal fragmentation. Let us explain with an example. Here, the first block size is 4 MB and the process size is 1 MB. Irrespective of the process size, the process is allocated to this block, which is of only 1 MB. So, 3 MB of 4 MB space is remains free. This is called internal fragmentation. So internal fragmentation means any program, no matter how small, occupies an entire partition. This is called internal fragmentation. Then next one is external fragmentation. In external fragmentation, the total unused space of various partitions cannot be used to load the process even though there is a space available but not in the continuous form. Here we have 3 MB free space, here 1 MB, then 2 MB, here 1 MB, total 3 MB, then here 2 MB, 5 MB. If a process P5 of 5 MB is come to the memory, but it can be allocated to this memory because the memory is not spanned, not in continuous process. So this is called external fragmentation. That means even though we have enough space to allocate the process, but it is not continuous. That is called external fragmentation. So next category is variable size partition. In contrast with the fixed partitioning, partitions are not made before the execution or during system figure. Various features associated with variable partitioning are: initially, RAM is empty and partitions are made during the runtime according to processor's need instead of partitioning during system figure. So before the execution or during system figure, the RAM is allocated. RAM is partitioned according to the processor's need at the runtime. That is variable size partition. The size of partition will be equal to incoming process, and the partition size varies according to the need of the process so that the internal fragmentation can be avoided to ensure efficient utilization of RAM. And the number of partitions in RAM is not fixed and depends on the number of incoming process and main memory size. So whole total, before the execution or during system figure, the RAM is partitioned at the runtime according to the processor's need. So we can eliminate the internal fragmentation, and the number of partitions in RAM is not fixed, which depends on the number of incoming processes. This is the example of variable size partition. Here we have a process P1 of 2 MB. So the RAM is divided into as the block size of 2 MB. Then process P2 of 7 MB. Then block size is 7 MB. Then P3 of 1 MB. The block size is 1 MB. P4 of 5 MB. And the block size is 5 MB. So the RAM is divided according to the processor's need at the runtime. Next, advantages of variable partitioning. First advantage is no internal fragmentation. In variable partitioning, space in memory is allocated strictly according to the need of process. Hence, there is no case of internal fragmentation. There will be no unused space left in the partition as we seen in the example. Then next is disadvantages of variable partitioning. The first disadvantage is external fragmentation. There will be an external fragmentation in spite of absence of internal fragmentation. For example, suppose in above example, process P1 2 MB and process P3 1 MB completed their execution. Hence, two spaces are left. That is 2 MB and 1 MB. Let's suppose process P5 of size 3 MB comes. The empty space in memory cannot be allocated as no spanning is allowed in continuous memory allocation. So this is called external fragmentation. For example, suppose process P3 and P1 completes its execution. So 3 MB space is available in the memory. And when a process P5 comes with the need of 3 MB, but we cannot allocate process P5 into this memory because it is not continuous. We cannot span the memory location. So next concept is non-continuous memory allocation. In non-continuous memory allocation, different parts of a process is allocated different places in main memory. spanning is allowed, which is not possible in other techniques like continuous memory allocation. So in non-continuous memory allocation, different parts of the process is allocated different places in main memory. So for a process, different parts of the memory can be allocated. So we can made spanning in non-continuous memory allocation. For example, suppose process P of size 4 KB. Consider main memory have two empty slots, each of size 2 KB. Hence, total free space is 4 KB. In continuous memory allocation, process P cannot be accommodated as spanning is not allowed. Here, the process is of size 4 KB, which is divided into 2 KB size. But in continuous memory allocation, we cannot be allocated this memory into this size. But in non-continuous memory allocation, this can be allocated into different parts of the memory. In continuous allocation, space in memory should be allocated to whole process. If not, then that space remain unallocated. But in non-continuous allocation, process can be divided into different parts, hence filling the space in main memory. So the 4 KB process is divided into two parts, one of size 2 KB and which is allocated to this part, and the other of size 2 KB which is allocated to this part. So that is called non-continuous memory allocation. So in non-continuous memory allocation, the entire process can be divided into different parts, and the different parts are allocated into different sections in the main memory. We can be allocated in different portions. We can allocate in the first portion, and we can allocate in the last portion, and so on. Here, the process is divided after analyzing the number of empty spaces and the size in main memory. Then only we divide our process. It is very time consuming process. The number as well as the size is changing every time due to the execution of already present process in the main memory. So in non-continuous memory allocation, the process is divided according to the empty spaces in the main memory. So it is a time consuming process. In order to avoid this time-consuming process, we divide our process in secondary memory in advance before reaching the main memory for its execution. Every process is divided into various parts of equal size called pages, and we also divide our main memory into different parts of equal size called frames. So in order to avoid this time-consuming process, we divide our process in the secondary memory itself. The process is divided into various parts of equal size called pages, and in main memory is divided into different parts of equal size called frames. Here the page size and the frame size are the equal. That's all about continuous memory allocation and non-continuous memory allocation. Thank you.